Hey, good day, everyone. And I guess it's a really good time to remember to unmute my microphone before I start talking. So welcome to number 10 in the series of DNSSEC presentations. Today we're going to be talking about debugging and troubleshooting. How do you deal with things that go wrong? And the biggest thing about this is that DNSSEC really is very binary. It's either working or it's not working. And when it's working, you get an authenticated data bit. And when it's not working, you get a SERVFAIL. So between those two things, we have to be able to figure out, why are we getting a SERVFAIL when we think we should be getting an AD bit? And perhaps why are we not getting an AD bit when we think we should be getting one? So let's talk a little bit about troubleshooting DNSSEC. And specifically, we're going to be using DIG. So when I first started these classes many years ago, I walked into the class and I started trying to debug things using NSLOOKUP. And that was really a pretty bad idea. And the reasoning behind it, or the reason that it was a bad idea, is that it's actually a little bit difficult to get all of the bits out of the header. So when you do a DNSSEC lookup in the DNS header, you're going to get back the AD bit. You're going to be able to, you need to be able to transmit the CD bit, checking disabled, and none of that's really that easy to do with NSLOOKUP. It's really not going to work well for you. But all you really need is dig and date. Those are really the only two real applications that you're going to need. And so, again, many years ago, when I was first writing the material for this class, I noticed that there was a zone that went away, that actually stopped working. And I was trying to figure out why it wasn't working. And I got in touch with Mark Andrews, one of the engineers here at ISC, and I started, asking him what debugging tools, what big, great, ideas did he have? And he was like, no, you don't need any of that. You just need dig and date. Now, having a few other things does help, but those are the only two real things that you need, the only two applications you need. So what we're going to do today is learn how to debug using dig and date. So any query that you ask for valid data from any recursor is going to provide the RR set in response. So if you ask for www.example.com and it's out there, you're going to get it back as long as, if it's valid. If you're going through a validating recursive server, then it's going to come back as validated. If you're getting it back from a non-validating recursive server, then you're still going to get something. You're going to get an RR set in response. Now, a query asked for non-signed data from any recursive server is going to provide that RR set in response. Now, the difference here is obviously the valid data being asked for from a recursive server that's doing validation is only going to come through if it is actually valid data. Now, if it's not signed, even the upstream validating recursive server is still going to pass it through, but it's going to pass it through without an AD bit, the authenticated data bit. So you need to be aware that if you ask for valid data from any server, you're going to get it back if it's good. If you ask for any non-signed data, you're going to get it back even if it's not good from either a validating or a non-validating server. A query asked of a validating recursive server for modified or invalid data for whatever reason is going to return a SERVFAIL. Now, applications and users are going to see this as domains that just go away, because very rarely does an application actually look and say, hey, end user, we got a SERVFAIL back instead of an NX domain or a no data response. They're just going to see this as something that went away. Now, it's not an unusual question when I'm teaching this class in person for people to say, but why don't we have another return code, that says, hey, this thing didn't validate, so, something's gone wrong with DNSSEC. And the reason is that you always have to go to the lowest common denominator. And in the case of a validating recursive server, yes, it could send back some type of an extended status message, but how do you know that the person on the other end, or the application on the other end, is up to date enough to know how to deal with that extended, extended response code? So what was done in the DNSSEC specification, anytime a non-validating, a signed bit of data, something that should be able to validate, if it doesn't work right, you always get back a SERVFAIL. Now, there is a header bit that says that you can do, checking disabled. You can, send a query, and even if the data is no good, even if it is a bogus response, you're going to get back the data in place anyway. So if you send a query for DNSSEC data and you send the CD bit, it's going to come back even if it doesn't validate correctly with the upstream server. So if I go out and I do a dig, for example, digging www.dnslab.org, a record, I get back a good answer. I see that this is the QR bit is set, so this is a response. RD, I did this with recursion desired, and RA is a response that says recursion was available from the upstream server. Now, I don't know at this point whether this is actually a DNSSEC validated response or not, because I didn't ask for DNSSEC. I didn't submit this query with the AD bit set, which would mean that the upstream would do authentication and just return the AD bit. So I don't know that this is necessarily good. So if I do this against a validating recursive server, it's guaranteed to be good data, assuming that the domain is signed and the chain of trust is intact. Now, if I get back a SERVFAIL when doing this, it may be that the server failed for some other reason. Maybe this is there's a lane delegation on this zone. Maybe, the upstream recursive server ran out of memory while it was trying to do the recursion. Maybe it was a CNAME chain that was too long and you got back a SERVFAIL. We don't really know why, but at this point, if we get back an answer like this, we know that it may or may not be DNSSEC signed, but we do have an answer back. We see a no error response, and we do see the 3 flags set. Now, if I do the same query, but I set the AD bit on the outbound query, so this is the authenticated data bit, which initially, when in the early days of DNSSEC, this was only used in responses, but there has been an update to the RFCs, or a new RFC actually, that says if a query is sent with the AD bit set, then the upstream recursive server should do validation, and it's going to echo back the AD bit saying, yes, I did the authentication, and yes, this is authenticated data. And different from sending the DNSSEC OK, the DO bit, it's not going to send back all of the RRSIGs. It's only going to return the response that I got back, the A record, and any other associated records, but not all of the additional DNSSEC stuff. So this time we did this query, we sent the AD flag, we know that we trust the upstream server, and we get back the AD bit. So in this case, we know that the upstream recursive server is doing validation. So to return that AD bit set, the domain must be signed, and the validating recursive server upstream must have a trust anchor that it was able to track back to. So from dnslab.org, it was able to go upstream far enough using the DS records to find the associated trust anchor that was embedded in the upstream recursive server. So if the chain of trust does not lead to a trust anchor, you're not able, the upstream server is not able to set the authenticated data bit, but the signatures will still be returned, assuming that I set the DO bit on the outbound query. So the zone data may be altered without an upstream validation failure, because if there is no trust anchor, then there's no way that we're actually able to prove that any of the keys in the chain are valid, and therefore we're not going to be able to set an AD bit, so you're not going to be able to get back a SERVFAIL if there is zone data that has been modified. So if you're going to sign your zone, make sure that you go ahead and put those trust anchors in place once you know that everything is working, and then your upstream server will be able to provide the AD bit and validation of all of your data. So if I do the same dig that I did previously, but now I'm doing the plus DNSSEC, so this sets the DO bit, the DNSSEC OK bit in the outbound query. If I get back the response with the AD bit set, then we know that the recursive server tracked all the way back to a trust anchor. But even if we don't get the AD bit set, we are going to get the signature data. So in this case, we see we have the A record and we see the RRSIG. And if we, as the end user, are smart enough to have, the knowledge of DNSSEC, we have the public keys that are needed, we can actually do the validation ourselves without the upstream server doing any work for us. Now, this is actually how a recursive server works, because a recursive server doesn't depend on the upstream server from him doing the validation and returning an AD bit. It actually does the tracking back itself. So if you are downstream from a non-validating recursive server, then you are able to do the validation yourself by requesting the plus DNSSEC, set the DO bit, you get back the signatures, and in this way, you're actually able to see the data and do the validation yourself. Now, right off the bat, I'm going to say this is not going to validate because I see dates that are in 2008. We'll get into that in a minute. So if we know that we're talking to a validating recursive server upstream, if we get a SERVFAIL, we may be seeing non-validating signed data. So we may be seeing bogus data. Somebody went in and modified something, or a date isn't in place, or there's data signed with a key that isn't there anymore. Something's wrong if we get that SERVFAIL. Now, the problem is that you can actually get SERVFAILs, and in fact, there's a lot of different ways that you can get SERVFAILs if you are not even doing validation. So one of the things that I would do in class, I'm a tricky guy, you know how that is. And one of the things in one of the labs, I would cause a SERVFAIL. And so when a class member would do a dig against a specific label, they would get back a SERVFAIL, but it had nothing to do with DNSSEC. It had to do with the fact that it was a lame server. There was a delegation above that pointed to a server that was not authoritative for the zone. And so the zone would SERVFAIL even without it being a DNSSEC related problem. So you can't immediately say, oh, well, we just turned on DNSSEC and this zone is SERVFAILing, so it's got to be DNSSEC related. Don't get focused on that tunnel. Make sure that you figure out why it's failing first. Look in your logs, and if you see, lame server or lame delegation, boom, you know right off the bat that it has nothing to do with DNSSEC. But if it is DNSSEC related, then what you can do to do some testing is set the CD bit in the outbound query. And this bit is defined as checking disabled. So what this is going to do is it's going to tell the upstream server, I appreciate you very much doing the validation, but I really don't want you to, send me back a SERVFAIL. I want you to actually send me back the data and let me deal with the consequences. So setting the CD bit is going to allow the upstream recursive server to send you the data even though it doesn't validate. So if I go in and I do a dig on www.dnslab.org and I get back a SERVFAIL, what I can do is I can then do a dig plus DNSSEC plus CD for the exact same label. And what I'm going to get back is whatever the upstream server thought was not valid data. For whatever reason, it didn't validate. So in this case, I'm going to look and I'm going to pretend, let's pretend that it's actually sometime in 2008, and these dates actually validate. What we're looking at here, I see a signature that just has a bunch of the letter X repeated over and over and over again. That is most likely not a valid signature. Now, I've looked at a lot of DNSSEC signatures, and I will tell you that most of them look very much like random, base 64 data. And if I just see a string of X's, then I'm gonna be able to guess that that is not a valid signature. Now, one of the things, again, that I did in class, and some of you, I think that some of you that are listening in on this may have actually been in these classes, and I hope you enjoyed them as much as I enjoyed teaching them. One of the things that I did was I actually took an RRSIG and I modified it, not as obviously as just a string of X's, but I actually put the string Kilroy was here in the middle of the signature. Now, that is something that isn't going to happen, again, randomly. I guess if we got a million monkeys and a million typewriters, you might eventually get a signature that has a string in it. But the signature being invalid is not always going to be as obvious as something with, just a string of X's. It may be, a cosmic ray just happened to hit one of these packets as it was leaving the router, and it changed an uppercase A to a lowercase a. Something that you as a human being are really not going to be able to see. So one of the things that you really want to do is, if you get something that, if all the dates look good and all the keys look good, and we're going to talk about that in a minute, you want to check if the signature is good, clear your cache, flush the cache, and do a dig again and see if you get back the exact same signature. Maybe it just got, maybe it got zapped in transit. So an invalid signature is going to show up as a SERVFAIL. If it's something as obvious as a bunch of X's or the word Kilroy was here in the key or in the signature, then you're probably going to be able to figure out that, yeah, that's not a valid signature. But under most circumstances, that's not going to be something that you as a human being are going to be able to determine. The dates in the signature. The dates in the signature are going to appear the same. You're going to get the same SERVFAIL from an expired signature that you are going to get from an invalid signature, or that you're going to get from a missing key. And what you're going to be able to do, do this dig, look at the dates. And I can look at this and say that 2011-05-27 and 2011-05-17, today's date does not fall between those dates. And therefore, this is an invalid signature. This is where you're going to use the date command to figure out what day today is, and you're going to be able to move forward from that. So one of the issues here, be absolutely sure that when you are doing when you're signing your zone, make sure that you have the correct date and time zone set on your system. Because remember, these dates are UTC. They're not based on your local time zone. And make sure that, when you generate signatures, that you're generating a valid set of signatures that have dates that actually work. So it's very easy to check the dates on the signatures, and it's much harder, humanly impossible, to find an error in a key or in a signature itself. The previous example with a bunch of X's is extremely contrived. You're never going to see that unless somebody's playing a really horrible joke, or if it's somebody in a classroom just trying to set you up with an example of figuring out why something isn't working right. Now, another big problem is a missing hash or a missing key. So if you go through a key rollover specifically for your key signing key, and you do this rollover and everything has worked perfectly, but you forget to modify the DS record in the parent, and you remove the old key signing key, and the anybody that's trying to do validation, using that DS record is going to look in your zone, and that DS record isn't going to match any of the keying material. And immediately your zone is going to go away. Also, DNS keys. So if, if the DS record in the parent doesn't get changed, it needs to be changed, obviously. If you delete the keys in the zone that you're doing the key rollover, then you're also going to have problems. And DNS keys, if you remove the zone signing key that is used to sign the zone before the data has gone out of the caches all around the world, the old signatures based on the key that you've just deleted, you may see sporadic failures to validate. Now, most DNSSEC software these days, and this is in 2020, are going to, if they get a failure, they're going to actually retry, and possibly, if you've taken out a key and replaced it with another key, they're going to see that the one key isn't there anymore. There should be a little bit of playing around with the cache, and it might just happen to work, but don't base any of your don't base your zone functionality on that. Do the key rollovers, as I told you, previously in the series. You follow those instructions, you follow the timing on those, and you're going to end up with a functional zone no matter what. So you're not going to end up losing a key. So if you do get validation failures and you think that maybe a DS record or a DNS key, it's not really hard to determine that failure mode as well. So what we're going to do is we're going to look at that same thing, the same thing that we were getting the failure for. We're going to assume that the expiration date and the inception and expiration date are correct. What I'm going to do is I'm going to get this, and now I'm able from this information to see that this record was signed, this signature was created with key number, with zone signing key 46704 in the zone dnslab.org. So now if I go out and I look for a dnslab.org DNS key resource record set and I don't find a 46704, then I may have found the reason that I'm not able to validate. So now if I go out and I do a dig plus CD, because I want checking disabled, because I don't know how far up the chain the failures are occurring, plus multi, because I actually want to see the additional information, specifically the key ID that dig is going to provide me. And I'm going to look for dnslab.org, and I'm going to look for the DNS key. I see a couple of things here. First of all, I see 256, and that shows me, that in the flags field, shows me that this is a zone signing key. And now I see that this key has key ID 46704. So now I see that the DNS key is in that zone. If it is not there, then obviously the data in the zone isn't going to validate, because the signatures refer to key 46704. If key 46704 isn't there, then we have a serious problem. So if I see that the DNS key is there, then I need to go up a little bit. So now let's look, and we see all of the DNS keys, and I see a 256 46704, that's the zone signing key, and I see 250 key ID 64249, which is a 257 flag, which tells me that that is the key signing key. So now I would look at the DNS key resource record set, see that it is actually self-signed using the 46249, and now I know what key ID the DS record in the parent should be matching with. So now what I'm going to do is I'm going to do a dig of dnslab.org DS record. And now I'm going to, I see that I have I sent a query. This is the response, recursion desired. I sent one query. There were 0 answers. That tells me that there was no DS record in the parent. So in this case, I should not have actually been seeing a SERVFAIL. I would have actually been seeing a no, I would not have been getting back an AD bit when I requested it, because with the lack of the DS record, there is no complete chain of trust up to the root, assuming that that's where my trust anchor is. So if I see that the DS record is missing because I see answer 0, then I know that I'm not able to validate. So the answer 0 is a no data response. The DS record does not exist. The server is still going to return DNSSEC data and all of the A records and everything else, but it will never be able to return the AD bit because of the lack of the chain of trust up to a known trust anchor. And believe it or not, that's how you do debugging and troubleshooting of DNSSEC. It seems like it's going to be really complicated, but it's not. The complicated part is all of the math, which we have to assume under the covers that all of the mathematics of the, the key generation and the signature generation and the validation of the signature with the public portion of the key, that's something that we as human beings are not going to be able to validate. So in this case, what we're going to end up with is basically doing a couple of digs, understanding what information we're actually seeing back. The AD bit, authenticated data, SERVFAIL, something upstream went horrifically wrong, whether it is an actual server failure or if it is a DNSSEC validation failure. The CD bit, being able to get this data, checking disabled, we're able to look at it even with the upstream server not being able to validate it correctly. The DS records, creating the chain of trust, and that's it. That is literally how you go about doing DNSSEC validation. Now, there are some tools out there. Within the NL NetLabs toolkit, there is Drill, which was then followed by the ISC. In more recent versions of Bind, you'll find the Delve command, which is actually able to do this tracing back of the keying material and the DS records. Also DNSViz. If you haven't seen this, go ahead and do a search for DNSViz. You will be able, it is a DNSSEC visualizer, which will be able to give you a graphical representation of this. But I'll tell you that what you can do with dig and date is all you're going to need, unless you really need a GUI to do it. So with that being said, it is 27 minutes into the presentation and I'm done. So we, always look at DNSSEC as being something that's extremely complicated. It really isn't as complicated as it used to be, because now we have tools that actually are very, very user-friendly in comparison to other things that we did in the past. And with that, I will open the floor to questions and answers. Or actually questions, and I'll try to provide some answers.
Well, maybe some of the audience will provide answers. Usually they do. Yeah, so we have lots of time for Stump the Expert questions. So there's two questions, first of all, from Salvador. What if there's a man in the middle between the client and the resolver that changes the AD bit? I believe that is an absolutely fantastic question.
And the issue here is that you have to trust the last mile. And yes, the man in the middle, the guy sitting between you and the upstream recursive server, or the person owning the upstream recursive server, is able to set that bit, and there is no validation on that without, the trust of that, the data communication between you and the validating recursive server. One of the things that I would highly recommend is running the validating recursive server as local as possible. And that might even mean running the validating recursive server on the same machine as the person or the application that is needing to see the validated data. If it's running on the same server and somebody is able to fake the AD bit, then you're in really big trouble. Now, Microsoft kind of figured this out, and said, yes, we're going to solve this entire thing by deploying IPsec everywhere on your local network and all the way up to your recursive server. So all you have to do to make sure the DNSSEC is working is secure everything. And that doesn't really work so well when you're talking about an internet service provider or something along those lines, or a large, a large non-Microsoft based entity, because deploying IPsec is not for the faint of heart and is not, a whole lot of fun. So yes, that is a very valid issue. Bring that recursive validating server all the way back to the client as close as you possibly can.
So that's basically, so Salvador's follow-up comment was, how does the client realize that, or is the LAN considered trusted? And what you've just explained is you have to trust your last mile, first mile, whatever you call it, or you could run your resolver locally. And that, Luis has kind of picked up on that, and he's commenting, I assume you travel with a bind recursive on your machine. And what are the kind of issues what are the typical issues that you would face while on the road using this setup?
Yes. Yeah. So yes, I do run a recursive server on my own machine. Whether I do that in a VM, unfortunately these days, believe it or not, I actually have a Windows laptop as my primary laptop that I carry around with me. And yes, that's painful, but I have the ability to run virtual machines. And so I will very often run a validating recursive server in a VM on my laptop and then point my name service to that VM. And yes, it's absolutely horrible. The response of OMG is quite valid. But one of the things, and so you asked about problems that I run into, and the biggest problem is there are so many places that I stay. Well, I used to stay, and I guess I don't stay anywhere anymore that I don't trust because of COVID. Yeah. There are so many places that break DNS in little subtle ways because, number one, they use DNS as part of their validation of you being a resident at the hotel. So they do redirection of whatever your first HTTP query is. They send you to a portal. By doing that, they are obviously faking the DNS data. And by doing that, if your first jump is to a site that their DNS is validated through DNSSEC and you're doing validation locally, then you're going to immediately SERVFAIL and it's not going to work. You're not going to be able to connect to that first site to even validate your, to validate your ability to go out and do things like that. So I do that. You have to basically do the initial work through the walled garden using or not using DNSSEC. Once you are, trusting DNSSEC, then you have a lot to deal with.
Okay. There's a comment that Delve is useful, the trace options in particular, which is nice to hear. That was from Ralph. And then a comment from Andreas. You can use the brew on Mac OS to install bind on your MacBook. I do that. That's the only way I install it myself. AnonBodev, I think, maintains that distribution. That is very convenient. And that looks like, oops, no, we have some more questions in the Q&A. Again, Salvador, if I have a zone with a lot of dynamic hosts in my server, is DNSSEC not recommended? Because every time a new host registers, the server has to sign the RR set again.
No, absolutely. You can do DNSSEC on a dynamic zone. And in fact, that's the only way I would, yes, it's going to cause some churn in your zone, but it's not going to be something that can't be, well, I take that back. make sure that your system and your infrastructure is going to be able to handle the additional churn. But I would absolutely sign any zone that I deploy today. There's no reason not to sign a zone other than very specific limitations, and that would be on, you know, hundreds of thousands of labels that are constantly churning. Yeah, that might cause a problem, but I don't think that that would be too big a problem.
Okay, here is another question or comment. I guess it's a question. What's a good practice to have redundancy with zone signing? So meaning, would you want to have multiple signer servers in different locations that don't interfere with each other while signing your zones?
Yeah, that's actually a really interesting question. And it's one of those things that I know that we had some customers that were doing this. So there are ISC customers that are doing this, and they are basically taking the same data and then running it through multiple signers, basically in parallel, and then only publishing one set or the other. As long as you have the same keys and you have the same, you know, the trust anchors in place, you have the DS records in place as expected, then it doesn't really matter if the signature was created on, you know, server A or server B. They're going to be different just because of the, you know, the way that the signatures are generated. There's some randomness in those. So it should work fine. You're going to have to deal with how you know, make sure that the data is right. If you're only using one signer, then you know where something went wrong. If you're doing it with two signers, then you have two different places that a signing problem could occur. But again, in this day and age, that's really not, that's not that big an issue. If you have if you have two signers, only one of which is actually publishing the data, and for some reason it breaks, you should be able to immediately just switch over to the other signer and, you know, use it as the primary server to all of your secondaries. It shouldn't cause any problems, even with it generating slightly different key material. Signature material.
So yeah, Luis made another comment about this. I know of a registry that has an additional DS in the root for a separate DNSSEC key that's to be used in case the HSMs that cause the regular keys go boom. Such key is allegedly kept offline, split into parts to ensure minimal quorum to use. I think, you know, this also goes to the, you were talking in a previous session about like putting in a backup key. I forgot what you called it.
Yeah, a standby key. Absolutely, that would not be a bad idea at all. You know, if you have a secondary, you know, a separate signing instance, you know, you have well, but then again, you should be, yeah, with the HSM would be a big issue there. If you're going to be publishing multiple DS records, make sure that the keying material for that emergency key, or for the emergency key isn't available. Make sure that it's stored very well offline, because otherwise somebody could come in and start doing, you know, bad things.
Right. So what we're talking about here are basically working around the different elements where you could have a failure. Could be in the HSM, could be in another signer. So yeah, Luis is commenting that activating a backup key can take a while. So it's a big advantage to have it ready to go, which is absolutely the whole point with pre-publishing that. So Salvador has another question. What's a good practice for managing private keys? Do you recommend a Git for storing the private keys in some encrypted way? I mean, you're talking about hiding them away safely. You know, almost by definition, that means that in a panic, somebody might not be able to find them.
Well, so the problem though is that the private keys need to be available to bind to do signatures, to create the signatures. So yes, keep them, secure, but remember that bind is going to have to be able to read them. So I'll go back to the other thing, the thing that Luis brought up, and that is the fact that the HSM is really the right way to do key storage, because the HSM is keeping the keys in hardware. It's keeping them away from, the bad guy getting in and stealing them. Obviously, it increases the price because HSMs, aren't cheap. The real hardware ones. There are some soft HSMs available, but you can't just store these and put them offline forever, because as soon as you need to re-sign the zone, if those keys aren't available, the private portion, then you cannot generate the signatures.
Okay, just looking to see, we have a couple more comments here. Can we have the same DS record with multiple TLDs? We serve a bunch of org common zones as well as our primary. This is from James.
Okay, so that would be basically, if you have the same DS record, that means that you're reusing the same key signing key. I wouldn't recommend doing that. Just, if you use the regular tools, you're going to be generating a new key signing key for each of the zones, and each of those key signing keys is going to have its own DS record. Maybe I'm misunderstanding, but yeah, you shouldn't need to reuse a key in this day and age. Maybe in the early days it would have been okay, but it's not necessary anymore.
So here's a comment and question from Andreas. A lot of enterprises are using professional IPAM solutions to manage DNS. What features or capabilities with regard to DNSSEC do customers have to check or evaluate to ensure they can actually use their IPAM solution for signing?
That's actually a double-edged sword, and thank you, Andreas, for bringing this up, because it's in several of my past lives, I have actually worked for appliance vendors, and DNSSEC has always been an interesting feature, because in the appliance it's very easy. You check the box and you hit the go button, and all of this stuff magically happens behind the scenes. The problem comes more when you're moving into an appliance or when you're moving out of an appliance. Now, moving into an appliance, it's not always necessarily easy to import an existing key set. So somehow you're going to need to be able to keep all of your existing data, including the existing public keys and all of these existing signatures, be able to pull them into your IPAM solution and have it maintain that while it does whatever its magic is in the background to create its own keying material and start serving the zone. Now that's moving into an IPAM solution. The other problem is moving out of an IPAM solution. And the problem you get into there is that very often, and in fact, I think with all of them that I'm aware of, you may not necessarily be able to get access to the private portion of the key. So if you're wanting to move your zone out of, solution A and into solution B, then you may end up having to remove your DS record in the parent because you're not able to get the keying material out of your existing solution to be able to create the same signatures in the new solution. Or you're going to have to do something where you have an extra set of DS records, maybe run kind of parallel, old infrastructure, new infrastructure. You're going to have to play some games, but that would be something that I would really bring up with my IPAM vendor is, what is the solution? And nobody ever wants to talk about how do I get out of, I'm buying into this thing. Why would I ever want to be able to leave? But that is a completely valid issue. And that if you run into problems, how are you going to be able to manage that key? Are you going to be able to get access to the keying material? Is it in a format that you're actually going to be able to use with whatever you are going to be transitioning into? It may be something that you need to talk to the professional services group at the company that you're moving away from, and they may not be that interested in assisting with that, unfortunately.
Yeah, sadly, that was one of the last really valid use cases for the DLV that we shut down, was that people were using it as a transition mechanism, a transition between products or providers. But anyhow. So that's the end of the questions. And Suzanne has been busy in the background looking at our registration data. And she has determined that we have 4 people who have been to every single one of these sessions.
That is absolutely amazing. I cannot believe that you guys have, that's awesome. Thank you.
Oh, okay, Jim has added another question. Jim is actually one of the 4, Jim at Blue Popcorn. When I query my own DNSSEC signed domain with the AD flag set, I'm not getting AD in the response, but I am getting AA. If I want to check for a DNSSEC valid response, do I need to check for either flag?
Okay, so you've run into something that in the class I would have gone over, and I probably should have gone over. Okay, that's it. We're going to have to start over. This has got to be in slide deck number 1. So we're going to have to start over. Next week, we're going to have, no, we're not. I'm kidding. That's a total joke. You only get the AD bit from a recursive server that's doing validation. You will not get it from an authoritative server for the zone that you're asking the query of. If you get the AA bit, you will never get the AD bit. Okay? So, and the reason there is that, you're asking the authoritative server, he is giving you as valid data as he can. There's no way that, it makes sense for him to do validation on that data because he's given it to you. So you'll have to run it through a validating recursive server that, again, has all the chain of trust in place.